I am Daniel Maldonado,
I'm Vanessa Ortiz.
and today we're going to present to you about ultra high performance concrete, also known as UHPC in industry.
So what is UHPC? So one of the main objectives for UHPC is obtaining a very high compressive strength of about 22,000 PSI. Obtaining a very high compressive strength is not the only criteria of importance. With UHPC, increasing the compressive strength alone does not lead to crack resistance, ductility, and durability. Looking at the table on the right, we can see the comparison of conventional concrete and UHPC. The table lists the following characteristics: compressive strength, tensile strength, and the elastic modulus. With UHPC, fibers are generally included to achieve specified requirements. Also, the matrix of UHPC is optimized for particle packing, that is, the mixed proportions of typical components such as sand, silica fume, and cement that are optimized to achieve the densest packing possible. What makes UHPC different? 75 to 80% of ingredients of UHPC are the same as compared to regular concrete, cement, sand, and water. It is the remaining 20 to 25% that makes the difference. The addition of silica fume and steel microfibers makes this concrete unique. These additions give the concrete a compressive strength of greater than 22,000 PSI, a tensile strength of about 900 PSI, and an elastic modulus of 6 million PSI. UHPC also has a very low water to cement ratio, which is less than about 0.25. And with the careful use of admixtures and accelerated curing, this gives the concrete a very high early strength.
Some field considerations to take into account when using UHPC is that due to the lack of coarse aggregates and the low water to cement ratio, both of these lead to longer mixing times, which is typically about 20 minutes for drum mixers. If you add fiber reinforcements, which is typical, it also adds time as you have to be putting in the fibers in a deliberate manner to ensure uniform distribution through the mixture without it clumping. Also, as you mix, you have to take into consideration the temperature, because if you mix for too long, it increases the temperature, which can result in a stiffer than desired mixture. And due to its highly flowable nature, forms are to be sealed in a secure manner and a deliberate manner in order for no seepage. In the US, structural design criteria for UHPC has not been fully developed. So there is no roadmap in using UHPC. So you have to know what you're doing. Some advantages of UHPC would include high strength, enhanced durability, low permeability, and its highly flowable nature. As you can see on the chart on the right, we have simulated conventional concrete with its relatively low toughness and durability compared to other concretes. Above it, you have FRCs, fibers reinforced concrete, which have pretty good toughness and durability and higher yield strength than conventional concrete. But at the very top, you see UHPCs, which have the greatest yield strength, the greatest durability, and the greatest toughness compared to all three of them.
Next, we'll be discussing applications for UHPC. So the first application we have are pedestrian bridges. As you can see from the pictures, the bridges are lighter and thinner compared to conventional cast concrete bridges. Besides having a very high compressive strength value, which exceeds 22,000 PSI, current research shows that UHPC is believed to have a high tensile strength value that may reach 1,700 PSI. With that, the bridge's self-weight is approximately 80% less than a similar bridge cast with conventional concrete. The reduction in self-weight resulted in a cost reduction of 10%.
Another application would be the use of UHPC in facades. Facades are used to act as a highly durable shield for the more non-durable materials being used behind it, such as glass and wood. In the picture shown, you have a UHPC facade covering a building that's mostly made of glass and wood. And the environment that the building is in is on a coast, which experiences some pretty harsh weather. And the UHPC facade adds a layer of durability for the materials behind it.
Next application for UHPC is rehabilitation. Here we have a few pictures of UHPC being used for rehabilitation. In the upper right-hand corner, we can see that UHPC can be used as a thin layer over older concrete to act as a shield due to its low permeability and higher durability.
Another application, which is pretty niche, is the safety and security. The 4-inch panels were installed to provide increased security against weapons effects on the roof of the structure. On the bottom pictures, you can see that the panels of UHPC are extremely thin compared to conventional concrete, and they provide roughly the same security. On the upper hand side, we could see, on the right hand side, we could see that the reinforced concrete and the UHPC concrete both sustain a blast at about the same distance. And the UHPC on the left-hand side is in much better shape versus the conventional concrete on the right-hand side.
So the last application for UHPC is highway bridges. Here we have a few pictures where UHPC is being used on highway bridges. The UHPC is added into the joints between precast members because of its superior durability. So here we have a video of North American bridges constructed using UHPC. As you can see from the video currently playing, the use of UHPC is gaining popularity. You can notice a cluster starting to form in the Northeast region where there is an abundance of freestall cycles, where most of these bridges are using UHPC in the joints between precast members.
So we've talked about all the advantages of UHPC. Now let's talk about the main disadvantage of it, and that being cost, of course. Conventional concrete sells at about $125 per cubic yard, while pre-bagged UHPC is at about $2,000 per cubic yard, and that's not including the steel fibers. The steel fibers for reinforcement sells at about $500 per cubic yard. Altogether, adding the steel fibers and the pre-bagged UHPC, we come to a total of about $2,500 per cubic yard, which is much more expensive than conventional concrete. However, some precasters, under the sponsorship of PCI, which is the Precast Pre-Stressed Concrete Institute, are in the process of developing their own mixture, which can result in a material cost of about $600 to $800 per cubic yard. And if you'd like to research more into UHPC, we have this works cited page with where all our information came from. Thank you.